If you're looking for a higher-end portable power station with high power output and battery capacity, fast charging capability using AC mains or solar, quality LFP cells, ease of mobility, as well as a long manufacturer's warranty, then this video is definitely for you. This beast of a power station was sent to me by Mango Power, and as always, you can expect a fair and honest review. To get started, let's go over the dimensions of this unit first. So 19.5 inches top of the unit to the bottom, or 50 centimeters, 13 inches deep from here to the back, or 33 centimeters, and 17 3/4 inches from left to right, or 45 centimeters. So a pretty large portable power station. This one is the biggest I have ever tested. Now, because this is so heavy, I really did not weigh it properly by holding it in my hands on a scale, but I can tell you it is approximately 75 pounds or 34 kilograms. So a pretty heavy unit. To make it easier to transport, you have these very comfortable grip handles, rubberized. So one person could be standing on that side, one on this side, hold it like this and walk. I could lift it up myself, I'll show you in a minute. And to make it very easy to transport, there's also this luggage handle that slides out of the unit. So let's take a look at me lifting this up, just to give you an idea of the weight. It is very heavy. Okay, so let me come around the back side of it, grab like this. It's pretty heavy. I'd say every bit of 70 pounds, so maybe 32 kilograms. So definitely doable to carry, but much easier to have two people, one on each side, lift it up. Over here's a look at the rear side of the unit. Push this button on top, it releases the handle, and it slides up and extends by 3 sections, just like a luggage cart, allowing you to easily transport this power station. Now the wheels, each one is a hard plastic wheel, and there are bearings on each one of these, as you can see in the image right here. Having this design in the wheels makes it easier to roll the unit on surfaces that are not perfectly flat. Rolls extremely easily. Push the button again, hold it, go all the way down until the handle's back inside the unit. You can see on this side of the portable power station, there's openings for ventilation to cool down the unit while it's either discharging or charging. Cells inside this unit are made by CATL. As you can see, the opposite side of the unit also has the ventilation opening to allow the air to go through the unit to cool it down. Below the ventilation opening is an access panel, and right on it, it states solar input. That's for charging up to an incredible 2,000 watts of power. Grid AC input charging up to 3,000 watts. E-Link port, that's if you want to connect two of these power stations together. You can actually create a 240 volt output. You would do that using this port. And over here it says E+ port. That's if you want to add a battery onto this unit to give you much more capacity, which is much more runtime. Let's pop open that cover. And it flops down. Each one is different number of pins, so there's no chance of confusing where the cable goes. This piece right here is rubberized. Slide it in and down, and it closes right up nice and tight. Included with this portable power station is this quick start guide, solar charging cable, as well as this AC mains charging cable. Warranty policy for this unit is 3 years and 5 years on the CATL lithium iron phosphate cells. This Mango Power E portable power station can supply up to 3,000 watts continuously, which we will definitely be testing out, and the battery capacity is 3.5 kilowatt hour. Easily expandable up to 7 if you purchase the additional battery, which plugs into the panel that I showed you on the side of the unit. For this product, the manufacturer gives a 30-day money-back guarantee, and that's a great thing because it shows that the manufacturer has a very high level of confidence in their product that people will be extremely satisfied. To turn on the unit, push for 1 second, let go, and it should boot up. Before I talk about this, let's go over the ports. Over here you have a 30 amp, 120 volt AC outlet. This outlet right here, or receptacle, is a TT30, also known as an RV30. If you have a recreational vehicle, you would want to connect to this receptacle to power your RV. Here we have 4 AC outlets. Each one is rated up to 20 amps. 20 times 120 is 2400 watts maximum each. Clearly you're not going to be doing 24 here and 24 there, because that would be 4800 watts, exceeding the power output for this unit. Over here you have a car outlet 12 volt receptacle, 10 amp maximum. Over here you have 12 volt 5 amp DC outlets. We'll check the power on these to make sure it can supply it. Over here you have a USB Type-C, 65 watt and 100 watt output. You have quick charge ports at the bottom, USB Type-A, 3.0, 27 watt maximum for this bank, and 27 watt maximum for that bank. To turn off the unit, you push and hold for 4 seconds, and then it should go off. So let's power this back on, take a closer look at that touch display. Looking closely at that touchscreen, you can see 82% state of charge for the batteries, and it says 46 hours, 21 minutes remaining. Up here it's solar power. Over here is your grid power. DC load, AC load. So if you want to power this section right now, you got to turn it on by simply touching it. And you just heard that relay click. There should be power at these receptacles. So I can turn that back off. Relay clicked off. DC load. Cooling fan is on very low. Now this whole section here should be active. Turn it off. Over here on the left side, you can see there's a battery. So when you plug in the unit to charge it, or even with solar, you should see this turn yellow. Over here is Bluetooth, Wi-Fi. This unit is going to have an app that you can use to control it and monitor the usage of power. The problem is it's a fairly new unit. The manufacturer told me the app is not going to be ready until the middle of November. So I will not be checking out the app in this video. It's something that you're going to get with your unit if you decide to purchase one after watching this video. Over here shows you if there's an additional battery plugged in, and up here at the top left it shows 2 units tethered together to give you that 240 volt output. What I'd like to do now is connect up the AC mains to this unit, see what kind of input power we're going to get going into this unit at 82%. That's the cable, 3 pins. It says SP21 series. Now you can see there's a white dot at the top. You want to take the white dot here, push it in, and then tighten the ring. Keep an eye here, I'm going to plug it in. Just heard a relay click. Hopefully you can see it clearly. Up here where it says grid, it says 492 watts. Now if you take a look over here by pushing the settings button, it says maximum AC input current. You could choose 10 amp, 15, or 30. Clearly if I'm in my house, I'm not going to have a 30 amp receptacle like a twist lock, so I'm going to leave it on the 15 amp setting. It says backup battery capacity 85%, and it says confirm. So I'm going to confirm. So now if I want to get the maximum out of my AC receptacle up to the 15 amp range, I would touch right over here, quick charge. Keep an eye over here. It's going to increase. Should go up to around 1600 watts. And then we're going to keep an eye over here, see how this goes up. Over 1600, 1660, 1678. All right, I'm going to let it sit a few minutes just to see how fast this starts to move up. And then I want to see how the cooling fans go, if they're noisy or not. So let's wait a few minutes, and I will be back. After about 10 minutes, you can see the jump up to 89. Grid 1665, cooling fan, not too noisy at all. Keep in mind, this would be much higher if you were using a 30 amp 120 volt input. Let's turn the quick charge off. Now it's at 90. It's going to drop back down to around 500 watts. Over here there's a button that says backup. So this also has the uninterruptible power supply feature. If you push this button, what's going to happen, this should drop. You heard the relay click. So now the power from the AC receptacle is going to flow through to these outlets. In the event of a power loss, it's going to very quickly switch to the battery in the unit. To demonstrate how that backup mode works, I'm going to take this old laptop, and you can see the battery has been removed. I'm going to plug it in. Now I'm going to open this up, keep it like this. A little hard to see, but it says Dell. Wattage 53. While this is running, I'm going to pull this out of the wall, and you shouldn't observe any interruption in the computer. Right now, let's do it. See, that's working good. Still loading. Now the power is coming off of, whoop, my finger touched that by accident. It's coming off of over here now where it says backup mode. So that works well. Let's get started testing the AC outlets. Depending on the charge rate that you choose with the settings, you can charge this unit about 80% of the way in 1 hour, or fully charged in about an hour and a half. I'm going to unplug this. Okay, and everything is now at 0. Let's take a look at the voltage output for the AC receptacles. 126 volts, very good. Let's measure frequency, see if it's 60 hertz. 59.66, close enough. Now we're going to take a look to see if the waveform is sine wave. Keep your eye on the oscilloscope. I'm going to power up the receptacles right now. And there you have it. Very nice sine wave. And the frequency is showing 60 hertz. Now let's take a look at the waveform under a high current load. Put that in. Hairdryer. 1,664 watts. Everything looking good. 125.2. Same exact thing. Alright, so we're pretty good on here. What I'm going to be doing in a little while is take this outside to make sure this unit has overcurrent protection. I'm going to place way more than 3,000 watts on these receptacles to make sure the unit does not get damaged from that load. After that's done, I'm going to let it cool off, charge to 100%, and then we're going to place a 3,000 watt load on the receptacles to see if the power station can handle that load and for how long. DC on, AC off. Reach straight into the back and to the side. 13.26. We're going to remember that voltage reading because after I complete the AC continuous power output test, when the battery is drained all the way down, I want to see what the voltage of this receptacle is. Very carefully, if I touch side, I have a steady hand for this one. Same thing. So these are all the same voltage. It's telling me a 10 amp maximum for here. So I'm wondering if it's 10 amp maximum for all three. The DC accessory socket is connected to my electronic load tester. It's set for 10 amps. That's the voltage, 13.29. When I turn it on, you're going to hear some beeping. Ignore it. It's going to be running though for 30 minutes just to make sure there's no problem at all with 10 amps coming off of that receptacle. Here we go. 121.6 watts, 10.013 amps. Okay guys, not a problem at all. 30 minutes. This only dropped 2%, so that is good. Now let's go on to the 5 amp test over here. Over here is the voltage, very close or the same as it was here. 5 amps. Let me turn it on. We'll wait and see how it goes. 61 watts. And this is showing around 70. Another successful test. No problems. It ran for about 20-25 minutes and no issues with it at all. Now that we know this can supply 10 and the small jack can supply 5, let's exceed the 10, make it 11. And it failed. Went on and off. Voltage is dropping too low on the output for that accessory socket. Okay, so let's turn this off for a minute. We know that this can supply the rated output up to 10 amps and this one 5. I'm going to exceed it by 1/2 of an amp just to see if it can work or hold. That just turned off. So 5.5 amps. Triggered it. This has no more power. Let's see if it auto resets. And it does, 13.3. What I want to do now is see if power is deactivated from this jack when it triggers. If it does, that means you can only have 5 amps in total for these 2 jacks. Yep, it was down to 0.4, 0.5, so that's off. And now it's back on. Now let's go on to the USB testing. Down here you have the quick charge 3.0. It says 27 watt maximum. And I'm wondering if it's for one or if the whole bank can only handle 27. So the easy way to find out is by placing a load tester on each one and exceeding that wattage. So let's give it a try. I'm going to let this sit for a while just to see how it goes. If it continues to run, that's an indication that each one of those ports has a maximum of 27 watts. I had it running for a little while, still showing 40 watts, which is higher than the 27. So to me, that's an indication that it's 27 watts per port. Let's move these over to that side and repeat the test. This section here appears to be working fine also at that 38 to 40 watt range, well above 27. I'm going to let it sit about 10-15 minutes, come back, and go on to the next test. Not a problem, same as before. So 27 watts must be an indication for each one, not the entire bank. A lot of power was just being drawn, and there was no issues. Now let's go on to USB Type-C. For the USB Type-C test, I'm going to have my tester set to 20 volts, which is the output voltage at 3 amps. 65 watts, 65. I'm going to let this sit for a while, come back, and let you know how it did. Not a problem, everything worked fine. Let me stop it. And now we're going to switch it to the other port, and hopefully I have the ability to go up to 5 amps, which will give us a 100 watt output. I'm now connected up to the right USB Type-C port, which is a 100 watt. Unfortunately, I just read the instructions that came with this tester, and it does not exceed around 3.2 amps. I wanted to go higher. Unfortunately, I can't, and I don't even have any devices that are going to be drawing up to 100 watts. So I'm going to repeat the test on the 100 watt section using approximately 66 watts. Here we go. Just as before, no problem. Let me turn this off. So we know everything here appears to be working very well. No issues. The 65 watt USB Type-C output, 100% certain, works fine up to that limit. The only thing I really couldn't test was the high end of this 100 watt USB power delivery Type-C. But I'd be willing to bet that it does work just fine. Okay, the power station is charged up to 100%. I think it was down to 83. And I gotta say, using the 15 amp setting on here, around 1700 watts, it didn't take long to get this up to 100%. Over here you can see the 100%, hopefully. Over here's the wattage you're going to be looking at when I do the testing with the AC receptacles. First, let me just put the hair dryer on here, take a look at the wattage, and then we're gonna keep adding. I wanna go over the 3000 watts to see if this has overcurrent protection. Okay, that's well over 1600 watts. Let me get my shop vac, turn it on, and then I'm going to turn on the hair dryer. And we'll see how high that goes. Okay, I'm going to turn on the shop vac first. That was 2,850 watts. No problem starting up the motor. It's an inductive load. Let me add something else to this to exceed the 3,000. Wow, that was impressive. 3,750 watts, and it ran for a while. Cooling fan going strong. Let me go a little bit higher. Let me get rid of this and then add a circular saw. Actually, maybe I'll leave that. There's a saw. If it doesn't trigger now with all this, I'll be shocked. That did it. Yeah, couldn't handle it. All right, so that's pretty good. You could probably get very close to 4,000 watts for a few minutes if you needed it. It probably should have no issue at all running 3,000 watts continuously. Charged all the way back up to 100%. I allowed this to sit for about 30 minutes just to cool off from the testing we did previously. It's already set. I have a load here that's going to be 2,960 watts. So just a hair under that 3,000 that they say this can run continuously. I'm going to turn it on. Hopefully it runs all the way until the battery is drained and this does not turn off before. Here we go. %, just shut off. This was 120.6 volts, very stable AC output voltage throughout the whole discharge cycle, and we ran for 58 minutes using 2,955 to 60 watts. So that's going to give us right around 2,900 watt hours for the battery using a 3,000 watt load. What I'd like to do now is take a look at the voltage of the DC accessory socket, put a load on it to see how it compares to when the battery was fully charged. It's been off for about 5 minutes, the power station. If I go to put on DC, the battery voltage is just too low. It will not turn on. So let me connect it up and see if we're able to charge it only 5 minutes after that kind of a test. I don't believe it. Only 5 minutes after that test. So the system apparently has very good cooling. Let me place around a 5% charge and then go back to checking out the voltage on this accessory socket. 5% now, did not take long at all. Let me put on the DC output. There's one thing I want to show you that you have to be very careful of, and hopefully the manufacturer changes this. You have the AC power cord, so if you plug this into the receptacle, before you plug this into the machine, there's a hazardous condition. The tips of each one of those contacts you could easily touch with your finger and get a very bad shock. This should have been the female, and these prongs should have been on the machine pointing outward. So be very careful, always connect this to the machine first, then plug this into the AC receptacle. I think the voltage was around 13.29 when I checked. And let's see here. Hopefully you can see that. We'll carefully go in here. 13.26. Now let me connect the spotlight back in here. Yeah, it looks just as bright. I don't see any issue with that. So let me just leave it on. And while it's on, I'm going to probe this wire, hopefully, see what the voltage is. Should be able to pierce it enough. So under that heavy load, it's about 11.5. But remember, it's going to be higher, the voltage over here, than 11.5. I'm going through a lot of wire. So very close to 12 volts, under load. If not, maybe slightly higher than 12. With this power station, you need to understand that the input voltage for solar charging has to be between 60 volts and 150. So that means I cannot take a 12 volt solar panel and just connect it to this. You're going to have to take solar panels and use them in series to increase the voltage to that level between 60 and 150. So I have two 400 watt solar modules. Each one is around 52 volts. Putting those two in series is going to give me 105 roughly, and I should have no problem charging this unit. I wish I had more than two of those 400 watt panels to test this with, but we're just going to connect those up to make sure the charging is working. Let's give it a try. Two 400 watt solar panels connected in series to increase the voltage, connected to the power station, and the input power is between 835 and 885, which is fantastic. Guys, I have to say, works fine. I don't see any issues with the power station. I hope you enjoyed this video. If you did, be sure to rate, thumbs up, and share. Thanks for watching.